Okay, so we already finished for the first fundamental or the skill you need to do well in this course. Next we go to the second fundamental on the electrical circuit, which is KVL and KCL. What is the meaning of KVL? Voltage law. KCL? Kirchhoff current law. Okay. So let's say I give you something like this. VI, VR, VC, VL. This is IR, IC, IL. Okay, I use magnet method for the single loop. It will be, you can directly easy to get the equation. However, let's say the equation have the circuit have 2 loops, 3 loops, so it will be quite confusing, is it? So we starting with the first loop for the fundamental. If you know that this is a magnet, when the negative magnet meet negative magnet, what's happened? Repel. So it means that it will be repel, we put negative, repel each other, is it? When negative magnet meet positive magnet, will be attract each other, is it? So attract will be positive, positive, negative, positive and positive, negative. So we use this thing lah as our reference. Okay, so now this is for KVL. Okay. What you need to do firstly, you need to look at this circuit. Whenever current go into a component, if the current go to a component, what is the symbol here? Positive or negative? Positive. When current go into a component, the symbol will be positive, go up is, and here will be positive and go here, negative. Okay. Now, we want to develop the KVL equation. Firstly, we must complete the positive and negative sign, and then you must know this info. And then what you need to do when you want to write down the KVL, you need to use one component as reference. In this case, I use our input as reference. So our reference will be positive VI lah. Must be positive, our reference. We put our reference as a positive sign. Okay. And then you look at the sign that going out from our reference is positive, is it? And then it will travel and meet the first component. The component is, when positive meet positive, what is the sign there? Negative. Okay. Negative, what is the value here? What is the thing there? VR. You must remember, this is KVL. So it means that this must refer to voltage. Voltage the input, voltage of the resistor, voltage of capacitor, and voltage of the inductor. Must refer to the voltage because this is KVL. Okay, now, that is travel again. Travel until it met the second component here. We must compare with the reference. So the going up from the reference is positive, and then it meet another positive sign, is it? So it will become positive and positive, negative VC. Okay, and then it travel again, and it meet another the final component. What is the sign here? What is the reference? Positive and positive become negative what? VL. And it travel again until it go to its original position. When it go to its original position, we can say equal to 0. Okay, done for KVL. So we go to the KCL, Kirchhoff current law. When we talk about Kirchhoff current law, we must look at the current. Not voltage, not the resistor value, not the inductor value, not the capacitor value. We look about the current, because Kirchhoff current law we look. So how many current that you can find here? 1, 2. There are 3 currents, is it? You find IR, IC, and IL. There are 3 currents here. So I just write it down. You can see 3 currents: IC, IL, and IR. There are 3 currents there, is it? Okay. The Kirchhoff current law definition is this is the definition of Kirchhoff current law. Let's say this is I1, I2, and I3. This is referred to I1 again because it's the same loop, same loop. Whatever current going through a junction is a total of the current going out from the junction. So it means that what is the current going through a junction? I1. And then it split it to how many junction? 2. It split it into I2 and I3. So it means that the value of I2 plus I3 actually equal to I1. Let's say you have RM 10 ringgit. And then you split the value of 10 ringgit to 2 people. The first people get RM 5. Second, you get another RM. Must be RM 5 lah. Kan? Because 10 ringgit, if you have 10 ringgit and you split 2, it must have the total of RM5, RM5 must be RM10. You cannot say that this is RM7, RM5. You give 10 ringgit, but the rest will get 12 ringgit. It's wrong, is it? Same thing with the current. Okay, so in this case, do you see any junction here? No junction, is it? No junction at all. Because it's a single loop. So what you can conclude that IR value actually equal to IC value equal to IL value. Same thing. Because let's say IR is 5 ringgit, do you share with anything? No. And then, so IC will also get 5 ringgit, is it? And then, so IL also get the same 5 ringgit because it's not shared with anyone. So this is your KCL. So it means that the KVL is VI minus VOR minus VC minus VL equal to 0. The KCL actually, the value of IR equal to IC equal to IL. Same thing.